Could the future of warfare ride beneath a bomber's belly? In 1931, Soviet engineers believed they could redefine warfare by launching fighter planes from bombers, a true flying aircraft carrier. Their goal was simple and urgent: to solve the crisis of Soviet fighters trapped by a 150-kilometer combat radius along endless frontiers. If they succeeded, they would rewrite the limits of air power. But what drove them from desperate calculation to such breathtaking ambition, and why did that future vanish before it began? Across the breadth of the Soviet frontier, the arithmetic of air power was unforgiving. The standard fighter of the early 1930s could reach no more than 150 to 250 kilometers from its base before fuel and ammunition forced a return. On a map, this combat radius became a narrow band, an invisible line of vulnerability stretching thousands of kilometers from the Baltic to the Pacific. Every kilometer beyond that line was a gap that no Soviet pilot could cross, a space where bombers ventured alone and unprotected, and where enemy forces could strike with impunity. The problem was not theoretical. Fuel calculation, flight plans, and theater maps all pointed to the same hard limit. A fighter, loaded for combat, was trapped within a circle barely wider than the distance from Moscow to Smolensk. The sheer scale of the Soviet Union magnified this shortfall into a strategic liability. Forward airfields could not keep pace with shifting front lines, and the cost of building new bases for every advance or retreat was staggering. Under these constraints, the dream of deep strikes, distant escorts, or rapid interception faded at the edge of the 250-kilometer mark. Soviet planners faced a dilemma measured in hard numbers, a dilemma that demanded an answer as radical as the geography it confronted. In 1931, a document crossed the desk of the Soviet Aviation Command that read like a challenge to the very laws of warfare. Vladimir Vachmistrov, a pilot and glider designer, proposed a vision he called a carrier without seas. The idea was as simple as it was radical. Use a heavy bomber, not just as a weapon, but as a flying airfield, capable of carrying smaller fighters attached to its wings or fuselage, transporting them deep into enemy territory and releasing them at the moment of need. This would turn a single aircraft into a mobile base, leaping over the endless distances that had trapped Soviet fighters close to home. The promise was intoxicating. Fighters, now freed from the limits of their fuel tanks, could escort bombers far beyond the reach of any airfield. Targets that once seemed untouchable, bridges, depots, convoys, hundreds of kilometers from the front, suddenly fell within the range of a single mission. The bomber, once a slow and vulnerable giant, would become a hub of firepower, protected by its own escort, able to deliver its payload and then call upon its fighters to strike or defend as needed. For a brief moment, the air seemed to offer the same strategic possibilities as the sea. The phrase mobile airfield captured the spirit of the age, a future where geography would no longer dictate the limits of ambition. In the hands of Soviet engineers, necessity became the seed of audacity, a plan to reshape the very nature of air power. The Tupolev TB-3 stood as a monument to Soviet engineering in the early 1930s. Its wings stretched 41.9 meters from tip to tip, wider than a modern passenger jet. The fuselage measured 24.4 meters in length, with an empty weight just over 10,000 kilograms and a maximum takeoff weight approaching 17,000 kilograms. 4 M17 V12 engines, each producing between 680 and 730 horsepower, delivered a combined output of nearly 2,900 horsepower. At full load, the TB3 cruised at 180 kilometers per hour, reaching a top speed of 225 to 230 kilometers per hour. Its practical range, when unburdened, extended to 2,400 or even 2,700 kilometers, enough to cross entire countries in a single sortie. The Polikarpov I-16, chosen as the Parasite fighter, introduced a different set of numbers. Its compact frame measured just 9 meters across the wings and 6.4 meters from nose to tail. The empty weight hovered around 1,340 kilograms, but with bombs and fuel, it climbed to 2,100 or even 2,200 kilograms. The Shvetsov M25 engine, rated at 650 to 700 horsepower, pushed the I-16 to a top speed of 460 to 490 kilometers per hour, depending on the variant. In combat trim, its range shrank sharply, from 700 to 900 kilometers without bombs, but only 150 to 250 kilometers when fully armed. These two aircraft, so different in scale and purpose, were forced into partnership by necessity. The TB3's vast wings and powerful engines offered a platform strong enough to carry the I-16s into the sky, while the fighter's compact size and light weight made them just manageable as external loads. Each TB3 in the Zveno SPB configuration carried 2 I-16s, bringing the total launch weight to roughly 22,000 kilograms. The engineering challenge was not just one of brute force, but of balance, load distribution, and the relentless arithmetic of fuel, speed, and distance. Every figure on the blueprint translated directly into risk and possibility. In March 1935, Soviet engineers achieved what many considered impossible: the mid-air coupling of 2 fighters to a bomber already in flight. The solution was a trapeze system, an articulated steel frame mounted beneath the TB3's broad wings. Each Polikarpov I-16, modified with a reinforced dorsal hook, approached from below at nearly matching speed. The pilot guided the fighter upward, aligning the hook with the trapeze crossbar. A gentle nudge, a mechanical click, and the fighter locked into place, suspended in the slipstream. The trapeze then drew the I-16 snug beneath the wing, distributing its weight of 2 tons through the bomber's reinforced spars and hardpoints. Fuel lines could be connected, allowing the mothership to top off the Parasite's tanks mid-flight. This system demanded precision. The geometry of the attachment, distance from the wing root, angle of the hook, and the flex of the steel under load had to be calculated to the centimeter. Any misalignment risked catastrophic structural stress. The load path channeled forces from the fighter's frame into the bomber's wing, amplifying strain with every gust and maneuver. To carry 2 Polikarpov I-16 fighters, the TB3's wings bore an additional 4,000 kilograms, altering the aircraft's center of gravity and flight characteristics. Drag increased sharply, cutting the mothership's top speed by at least 20 kilometers per hour and raising stall speeds. Fuel consumption soared, but for the first time, disparate airframes became a single composite system, fighters and bomber fused by steel and necessity, able to cross distances neither could manage alone. The proof came in a single, silent moment. 2 fighters locked beneath a bomber, all 3 aircraft united in flight, awaiting the signal to separate and strike. Every test flight with the Parasite fighters exacted a price, measured in hard numbers and quiet apprehension. The TB3, once capable of 230 kilometers per hour, lost up to 30 kilometers per hour when burdened with 2 I-16 fighters. Stall speed crept upward, sometimes by as much as 15 kilometers per hour, narrowing the margin for error on takeoff and landing. Climb rate, already modest, dropped by nearly half, and a loaded TB-3 could barely outpace its own shadow, struggling to gain even 1 meter per second. Fuel consumption soared, with the mothership burning up to 40% more fuel per hour, shrinking its range from a theoretical 2,700 kilometers to just under 2,000 kilometers. The numbers, once promising on paper, now revealed a different truth in the logbooks. Every added fighter dulled the edge of performance, and every mission carried a heavier risk. In August 1934, that risk became reality. During a Zveno 3 test, a composite formation failed to recover from a shallow dive. The cause, whether structural fatigue, aerodynamic stall, or simple miscalculation, remains lost to incomplete records. The result was unambiguous: the loss of aircraft and crew. For the first time, the cost of ambition was counted not in rubles or kilometers, but in lives. Engineers and pilots pressed on, but the optimism of earlier trials gave way to a more somber arithmetic. The sky, it turned out, was not as forgiving as the drawing board. On the morning of July 26, 1941, 3 TB-3 bombers lifted off from Yevpatoria airfield. Each carried 2 Polikarpov Mi-16 fighters loaded with bombs. The 6 converted motherships represented the entire operational fleet of Zveno SPB systems. No more would be built. That day, 12 Parasite Fighters were released over the Black Sea, striking Axis oil depots near Constanta. The mission reached targets that lay well beyond the reach of conventional fighters, proving the composite system's technical promise in the unforgiving arithmetic of war. Yet the cost of this achievement lingered in the background. Each sortie required meticulous preparation, rare fuel, and a dwindling cadre of pilots trained for the delicate coupling and release. In the weeks that followed, a handful of additional missions were flown, but the program never expanded beyond its 6 TB-3 conversions and 12 modified I-16 fighters. By 1942, official procurement records show no new aircraft assigned to Zveno SPB units. The experiment concluded not with a public announcement, but through silence in the ledgers and the quiet dispersal of the remaining crews. By 1943, the flying carrier had vanished, its promise overtaken by newer doctrines and the relentless pressure of total war. The vision that once sought to turn the sky into an ocean faded, leaving behind only traces in archives and the memory of a final, distant sortie. Today, the largest aircraft still struggle to match the TB-3's 41-meter wingspan. Yet no design has dared to carry fighters into battle since. As drones and autonomous swarms redefine air power, the dream of airborne arsenals lingers. Ambition outpaces practicality, but vision always leaves a contrail.